So is there innovation that's being done in the materials
Yeah.
technology at SpaceX where you're constantly trying to find and tweak a better version of this?
Yes.
And
It's a very difficult problem. No, it's a problem no one has ever solved. So we've got to get the exact right materials combination, uh, the right molecules in the right shape, and then apply that heat shield perfectly to the rocket with no mistakes. There's a reason that no one solved this before. So, like I said, we've had to vertically integrate the entire manufacturing of the tile from basic raw materials to a finished tile. Build the entire supply chain from basic raw materials. So you're just inputting silicon and aluminum oxides.
and what is the difference between the way you guys do it versus the way they used to do it for the space shuttle?
Well, I mean, the space shuttle, like the space shuttle leading edge, used like quite dense carbon tiles. Like it was, they're like basically thick and heavy, but also subject to cracking. That's like what happens. The foam broke off and it hit the tile, cracked the tile. Then on entry, the tiles that have been cracked or broken weren't able to shield the shuttle, and so the plasma got in and melted the primary structure, and the whole space shuttle broke apart.
Yeah.
So you can't have something that's as brittle, brittle like the space shuttle.
There's footage of that, right?
Yeah.
Yeah.
And it rained debris over the whole United States. So
Yeah.
And they got almost all the pieces. The full technical explanation would I think be understood by about 6 people listening to this. There was a lot of brilliant engineering in the space shuttle tiles, and a bunch of the heat shielding wasn't even tiles. It was actually silica blankets, felt blankets essentially. If you look closely, you'll see it actually is. They're actually heat blankets, not tiles in some areas. But they would have cracked tiles, and they would have occasionally the tiles would fall off. There were a few close calls